Hello everyone, it's time to continue our Rust journey with Rustlings. And last time we finished the quiz number 3. The no more quizzes, maybe fortunately, maybe unfortunately, depending on how you look at it. And today we're starting out with lifetimes, okay? I would say lifetimes, they're kind of pretty scary if you come into Rust. Personally, I kind of understand what they are, but I never had to deal with them. I have some surface knowledge about them. Basically, that they exist. And kind of what they mean, but nothing much in terms of practical knowledge on that times. Okay. And actually this time they're giving us a link to Rust by example. Because all the previous ones, they were from the last language book. So lifetime is a construct the compiler, or more specifically the borrow checker, uses to ensure all borrows are valid, specifically a variable's lifetime begins where it's created and ends when it's destroyed. While lifetimes and scopes are often referred to together, they're not the same. Okay. So what's the difference between scopes and lifetimes? They kind of trying to show you this. So basically, I don't know if I should try to explain because I better understand myself. So what happens is, this is I, we create I. Starts, it's like quote unquote live. Okay. And so here we borrow I. Alright. And we actually borrow it 2 times. So we borrow 1 and borrow 2. And each borrowed reference, it has its own lifetime. And first of all, just stop saying after every word. And second, you can see the braces. And they signify the scope. So here we can see 3 scopes. First one is the scope of the main function. Then we have this scope, and we have this scope. I think that they kind of provide a bad example, because they're trying to say that scope and lifetimes are different things, but in this particular example they're the same, to be honest. Okay. Again, lifetime is a period in the code where the variable is used, okay? And now they show us how to annotate it. But I think we need to first look at the exercise we need to solve. maybe this will help us to kind of see what this is all about. So again, the Rust compiler needs to know how to check whether supplied references are valid, so that it can let the programmer know if a reference is at risk of going out of scope before it is used. Remember, references are borrowers and do not own their own data. What if their owner goes out of scope? Okay, so here we have the function longest, and it takes two references of, two string slices, which are kind of references, and return a string slice. Depending on which one of those initial strings is longer. And this gives us an error. Why? Function's return type contains a borrowed value, but the signature doesn't say whether it's borrowed from X or Y. Consider introducing a named lifetime parameter. Alright. Let's read the language book. The main aim of lifetimes is to prevent dangling references, which cause a program to reference data other than the data it's intended to reference. Consider the program in listing 1016, which has an outer scope and an inner scope. So the outer scope they talk about is the main functions scope, and the inner scope is this one. And so what happens is we have a variable let that they actually don't initialize. Then in the inner scope we create a variable x. Then r becomes reference to x, but you can see that x only exists in this inner scope. So this will give us an error. Yes. I think I can do just here. So we're gonna call it lifetime. Right. Lifetime. Rest. Just copy that. I don't think if you can do it like this, maybe. I know we can compile it with Rust. Let's see, can you should run it? So this way we're gonna build it. To build either with a crate. To build either with a crate. Build executable, okay. Debug info, okay. It's gonna run it though, like this. But we don't really need to run it though. I need to just see the error message, which is which basically we're trying to borrow a value that will be which will stop existing at the end of the inner scope. Yes. This is what I just explained. This is the error. So, yeah. Generic lifetimes in functions. You write a function that returns the longer of two string sizes. Yes, that's basically the exercise they give us. Note that we want the function to take string slices, which are references rather than strings, because we don't want the longest function to take ownership of its parameters. On compile. I mean, why wouldn't it compile? We have two references, and we're trying to return one of them. I think that the problem is that we end up with one of those references, either X or Y. But the compiler wants to check like which reference kind of survives the lifetime of the function, but it kind of can't do this because it's a conditional result. I still don't understand how lifetime. I mean, I kind of understand like why this is bad, but I still don't understand why we need that. Time annotations don't change how long any of the references live. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetime. I see, so yeah, I think we get it. Basically, it says that this function has this lifetime, and all of the references is gonna survive it. I mean, that doesn't matter if we pick X or Y. Can't like can break before the function finishes its work. I think I can understand. Still, just gonna do it now. So yeah, we need to provide it a lifetime. I'm gonna call it A. then you're gonna have same lifetime A. This one also gonna be A. Of course, this is gonna be the way to do it. But then dealing with strings again. I'll change this function. So this is the function that we had. Fix the compiler error by moving one line. So what's the issue there? We have to string. And well, one of those strings will get destroyed here by moving one line. Well, there are two ways to deal with this. Basically, we can do like this. It will fix everything. It's kind of weird that it didn't like format it out for me. Let's check out the solution. I mean, I think I get what they meant, but yes, we can do this, right? And then the second solution, we can do this. Okay, makes sense. Lifetimes are also needed when structs hold references. The compiler error about the struct. Okay, so we create a book. So I see what we're trying to do. We're basically saying that like those references we pass to the struct, they should be valid to the lifetime of the struct. Okay. So we're basically going to do like this, right? Let's check out the solution to this one. It's going to be lifetimes. 1, 2, 3. Okay, makes sense. Now we're going to tests. Tests are important to ensure that your code does what you think it should do. So this is the function, is even, and have the assert function, right? Assert what though? Let me find it real quick. Okay, so it takes 2 arguments. I see. So we're gonna take number 4. Number 4 is even. So okay. So give it a message. So we don't really need to give it a message, right? There's an argument, but this is Boolean. Not found in the scope. Why? So in the use, I guess, like this, and then this gonna work. Okay. Once do this, now we're gonna do just that. Let's see the solution just in case. Yeah, it kind of expected us to test the opposite one, but kind of in my head there is also like the cert, or no, we have some macros right here. Yes or no. No? Okay. Weird. No, I probably should have done it like this. My bad, to be honest. It's gonna give an error. Now it's fixed. Good. Calculates the power of 2 by using a bit shift. Is equivalent of 2 to the power of n. So the power of 2. Okay. Okay. You want to test it. This is actually easy. So this is unsigned. It starts with 0. And if you're gonna have any kind of number in the power of 0, that's gonna give us 1. Then for 1, gonna give us the number, and so on. Let's do this. Am I correct though? I think I'm completely wrong. It's right. Okay, this looks good. I still want to see that solution. We're gonna test 38. Kind of similar. Next one. Then change this function. Returning a result would be better here, but we want to test functions that panic. So we have a function that kind of panics, and this is kind of bad. We don't want this to happen. Well, this test should check if the rectangle has the size that we pass to its constructor. Okay. Check width, check height. Width. Yeah, I mean, should just give it then like unsigned 16 bytes. Never mind. This test should check if the program panics when you try to create a rectangle with a negative width. So I think we have to actually go ahead and do a bit of reading. Writing tests. Let's just start searching for panic. I see. But that's not what we want. What we want is to check if it's gonna panic or not. We don't want it to panic. And how we're gonna do this. Actually, we have this. Okay. Nothing really does. Nothing. So we do like this. Let's copy that one. Okay. Yes. Oh, the fun part. Traders. When performing operations on elements within a collection, traders are essential. This module helps you get familiar with the structure of using an iterator, and how to go through elements within an iterable collection. You can optionally experiment here. So we have a list. I mean, it's not Python, it's an array. Okay. And then we want to create an iterator and actually know how to do this. Use an iter method. And what now? So next one gonna be banana. And this one gonna be and this one gonna be and at last it's gonna be none. Easy. Iterators. Let's go. Maybe we can finish this today. This exercise you'll learn some of the unique advantages that iterators can offer. Complete the capitalize first function. So we get reference the string size, and then those strings, string size gets converted to characters, offset string. Which would seem to be an iterator. So what it does basically checks, I would say, the length of a string. Does it in a kind of weird way, to be honest. But who am I to judge? So take this. What can we do with the character? Okay. What's wrong with my... see. What can we do with the character? So we need to do something like we now know we have at least one character. We have a reference, we have a slice. We can do like this. How do we slice again? I forgot. Like this, right? No, it's less like this, better like this. Can't find value, well, because this is a character. To it all. Okay, but can we do this? To string. No, we can. Well, how about string from first? Alright. No method named, well, maybe it's called capital S. Oof. Why is this so hard? Let's search for what kind of methods does string have. Should have something like capitalize. Oh, we have to lowercase. Oh, it's gonna be two uppercase. I see now. Wow, this is a good fix. I mean, this feels kind of ugly. But should snake case name? So it's not variable. Not variable. Excuse me. Apply the capitalized first function to slice of string slices. Well, easy. Words. Peter. Mouth. Done. No? No, not done. Oh. We have a reference. Ooh. It's kind of double reference, right? There's something. Okay. Okay. Apply the capitalize function to a slice of string slices. Return a single string, so we need to collect them. I mean, we could call the... We just call that. Wow. That's kind of not the point, is it? Yes. Exactly. Gonna go with that. But this shouldn't be collect, should be reduce, right? Should check out. So it's an iterator. Okay. And what it has is a map. You know, it has a map function. But it should have something like reduce. See? So reduce it is. So it takes what? Takes this and takes this. So this is kind of weird. Give it the initial value, right? Found extra argument. I think I broke something. I think I broke Rust, guys. What happens there? What does Phil do? Okay. This looks good. But then we should just do... Good. I mean, this should be then. Okay. Okay. Well, I think we should make this kind of pretty, quote unquote. We can do something on both sides. This can be just the... While at the same time, this one, you know, like this. I really like kind of Rust iterators. Or should we keep this as this or not? Then we should do this. And the problem is only this one. I see. Mismatch types. Okay, how this is wrong. Consider borrowing there. Well, this pattern creates a reference to a reference, which they say is a needless borrow. I should get rid of this. Okay. Well, then we can just do this. Why? Like, it allows me to do this. Like, I don't understand, like, what's the problem? Type mismatch. How is it a type mismatch? We'll give it a... In what way does it type mismatch? In what way? Like, why I can do this? But if I just give it a function, it's a type mismatch. Weird. Let's see the solution. Traders, right? So this is kind of what we did, I think. Well, not really. Kinda. Because this is an iterator. And we just took the first one, right? You know what it does? As a string, yes. Makes sense. Just kind of more clean, you know. You can uppercase a character, good to know. And this is... Wait. How's this the same? Wait a minute. It can figure this out? No fucking way. Is Rust that smart? I don't need like folding in this. Insane. Insane. Oh, good to know. So we have a division error. Divide by 0, integer, overflow, and not divisible. So we have a divide function. Gives us two integers, specifically two signed 64 bit integers. and we need to try and divide them. Well, what can we do? I actually kind of forgot how we do this. I guess you can do a match statement, so you take like this and what? And you like do this, and then the first one is like if it's a 0, and just like, well, that's an error, right? A division error, and we give it nah. So result can be this. And like this. Okay. Integer overflow. So they say that the only case is if we take a minimal signed integer and try to divide it by -1. Well, not happening, right? So we check for it. But I think we should just use that. If b is 0, well, that's an error. Else, if a equals to I64 and is like and like this, and b equals to this. It's gonna be an integer, right? Oh. Then another check. Okay, so what's wrong there? If maybe missing an else doesn't miss anything. Maybe we should do I'll say it says this is unnecessary. Yeah, do it. And now it thinks it's okay. Wow, whatever. So, in the case where if we try to like get a reminder of a division, right? And we get when we don't get a 0, then it's not divisible. And else we just return. Okay. That should be good. And it isn't. Why? Why it isn't good? Looks good to me. Okay, so we did this. And then we need a correct return type. Result of list. and complete the function body. This is desired output. Well, so then it's gonna be read out of this and here. We need to give it a size. Oh, figure out how to give it a size. Yep. So it's an array, right? Yeah, make it a vector. I see. It's the wrong size. Maybe the compiler would be nice now and point it out. This doesn't have a size. Obviously it doesn't. I agree here. So you can't really recommend me what to return unless I kind of try to return something. So we use this. And we need to divide. This is an iterator. And so what we need to do? We need to do like this. No, I can't do it like this. Why? I can't do this. So this function should return result or option. Oh, it does actually return result. Radar can only be used in a closure that returns result or option. I think I need a break.